Hey everyone, and welcome back for another deep dive. Today we are going deep into the world of spinal anatomy.
Ooh, exciting.
Yeah, and we're focusing on something called a cranial shift, which honestly I had never heard of before I started prepping for this deep dive.
Yeah, it's a pretty niche topic.
Yeah, but like most niche topics, once you start looking into it, it gets really interesting.
Oh, absolutely.
And we'll be diving into some brand new research that you, dear listener, are like among the first to hear about.
Hot off the presses.
Yeah, so get ready to have your mind blown because we're going to be exploring how these shifts, basically when parts of the spine appear a bit out of place, might be way more common than anyone thought.
And especially in people with scoliosis.
Exactly.
All right.
But before we get ahead of ourselves, let's break it down.
Okay, let's do it.
So what exactly is a cranial shift?
Okay, so picture this.
Yeah.
Most mammals have a pretty predictable number of vertebrae in each section of their spines.
Right.
Right, like 7 in the neck, 12 in the mid-back, 5 in the lower back, and so on.
Yeah, makes sense.
But the human spine, well, it likes to throw in a few curveballs.
Oh, really?
Yeah, especially at those transition zones between the different sections of the spine.
Interesting.
And that's where these cranial shifts come into play. It's like, imagine, if you will, the bones in the spine getting a bit squeezed upwards towards the head during development.
Okay, I think I'm starting to get the picture.
Good.
Now, the study we're looking at today really zoomed in on cranial shifts.
Yeah.
Specifically in adolescent idiopathic scoliosis, or AIS.
Right, AIS.
And get this, they've even given a specific name to a specific type of cranial shift. They're calling it Abul Cranial Shift, or ACS for short.
Catchy, right? Right.
Yeah, definitely rolls off the tongue. Okay, so I'm picturing these vertebrae getting all jumbled up. But what does ACS actually look like on an X-ray?
All right, think of it this way. If your spine were a game of Tetris, ACS would be like a combo move where the bottommost block,
Okay.
which would be your 5th lumbar vertebra, or L5, fuses to the row below it, which is your sacrum. And at the same time, a block goes missing higher up because the 12th rib is either super tiny or completely absent.
Wow. So it's like our spines are playing a secret game of anatomical Jenga.
Haha, pretty much.
Okay, so the researchers looked at X-rays from 187 AIS patients who had undergone surgery. And get this, almost 20% of them had ACS.
Yeah, it's way more common than we initially thought.
That's wild. I had no idea.
And what's even more interesting is that this cranial shift was way more common in females.
Oh, really?
Yeah, 21% of the female patients had ACS compared to just 5% of the male patients.
That makes you wonder if there's something about how the female spine develops that makes it more prone to these shifts.
Definitely raises a ton of questions.
It does. And hold on, it gets even more interesting. They found that 22% of those folks with ACS also had another spinal quirk called a posterior neural arch cleft formation.
Or NACF for short.
Yeah, alphabet soup. I know. What in the world is NACF?
Okay, so NACF sounds complicated, but it's basically a gap in the bony arch at the back of a vertebra. So imagine a small break in the bony ring that protects your spinal cord.
Okay.
That's essentially what NACF is.
Gotcha. So then why is it so important to understand ACS, especially for surgeons?
Well, think about it. Imagine a surgeon using a map where all the landmarks are in the wrong places.
Ooh, that's a good analogy.
Right. That's essentially what happens when a cranial shift is missed during surgical planning. It can lead to complications, ineffective treatment, or even damage to the spinal cord itself.
That's scary. So those seemingly subtle variations in vertebrae placement can really have a ripple effect across the entire spine.
Absolutely. One change in the spine can put stress on the vertebrae above and below it, which can then lead to problems down the road, like accelerated degeneration of the disc above a sacralized vertebra.
Wow. So it's not just about understanding where each vertebra should be. It's about realizing that those seemingly small variations can impact the entire biomechanics of the spine.
Exactly. It's a great example of why a holistic approach to spinal health is so important. We can't just focus on the curves associated with scoliosis. We need to understand how the whole spinal column works together.
That makes a lot of sense.
Yeah.
Okay, so before we move on to part 2, where we'll explore the broader implications of these findings, let me quickly recap what we've learned so far.
Go for it.
So we've discovered that cranial shifts, specifically a type called Abul Cranial Shift, are more common in AI's patients than previously thought, especially in females.
Right.
And these shifts can have significant consequences, particularly when it comes to surgical planning.
Exactly.
We've also seen that understanding ACS is crucial for surgeons to avoid wrong-level surgery, and that these seemingly small anatomical variations can impact the entire biomechanics of the spine, highlighting the importance of a holistic approach to spinal health.
Couldn't have said it better myself.
Great. So join us in part 2 as we explore what this all means for you and delve into potential research avenues this study has opened up. See you there.
See you there! Welcome back to our deep dive on cranial shifts.
I'm ready for more.
All right, so as we learned in part 1, these subtle variations in spinal anatomy can have a big impact on the whole spine.
Yeah, especially that Abul Cranial Shift or ACS thing. It really blew my mind.
Yeah, ACS is definitely a game changer. And it brings us to a super important point. The importance of, really thorough imaging when it comes to any spinal condition.
Makes sense. If a doctor's only looking at a limited part of the spine, they could miss these shifts completely.
Exactly. It's like trying to solve a puzzle, but you only have half the pieces.
You need the whole picture for sure.
Right.
Right.
And that's where being an informed patient comes in. You know, if you're aware of these potential variations, you can ask your doctor the right questions.
And make sure they're looking at your spine holistically.
Exactly.
So what kind of questions should listeners be asking their doctors? Like, what should they say?
Well, first off, if you're dealing with any kind of back issue, don't hesitate to ask about the possibility of a cranial shift.
Okay.
You can specifically ask if a full spinal X-ray is necessary to rule out ACS or other variations.
That's a good one. I'm writing that down.
Good. Knowledge is power.
It is. And this whole research project got me thinking, what if these cranial shifts are even more widespread than we realize?
Interesting thought.
Like, what about people with less severe scoliosis or no scoliosis at all? Could ACS be playing a role in other back problems?
That's the million-dollar question. You know, if nearly 20% of the surgical AI's population has ACS, imagine how much higher that number could be in the general population.
Whoa, yeah, that's a scary thought.
It is, and it makes you wonder if maybe full spinal X-rays should be more routine, especially for young people.
Yeah, so we could catch these shifts early on.
Exactly. Early detection is key. Because if we can identify these shifts early on, then maybe there are non-surgical things we can do to help.
Like what?
Well, think about it. Could specific types of physical therapy or bracing help to manage ACS? Could we develop new techniques to address those biomechanical stresses we talked about earlier?
Wow, so many possibilities.
Yeah, it opens up a whole new world of research.
This is so cool. But I'm curious about what causes these shifts in the first place. Is it genetic, environmental, or like a combo?
That's a great question. And unfortunately, this study didn't really dive into the causes of ACS.
Oh, bummer.
Yeah, but it definitely points to the need for more research in that area. You know, are there certain genes that make someone more likely to develop a cranial shift? Do lifestyle factors play a role? We need to figure that out.
Yeah, for sure. And what about the long-term implications of ACS? We talked about the surgical risks, but what about like pain mobility issues or even other spinal conditions down the road?
Those are all valid concerns, and we need more long-term studies to understand how ACS might impact people's lives over time. You know, does it increase the risk of arthritis or disc degeneration? Does it make people more prone to back pain or injury? So much more to learn.
I feel like we're just scratching the surface here.
We are. It's like we've opened Pandora's box of spinal anatomy.
Love that analogy. Okay, so before we move on to part 3, where we'll dive even deeper, let's recap what we've discussed in this part.
Sounds good.
Okay, so we talked about the importance of thorough spinal imaging to detect cranial shifts, especially since ACS might be way more common than we currently think.
Right.
We also brainstormed some potential research avenues, like investigating the causes of ACS and its long-term effects. And we even touched on the possibility of non-surgical interventions that could help manage ACS if it's detected early enough.
All super important stuff.
It is. All right, so join us in part 3 where we'll tackle some of those big questions we just raised and explore the potential for a whole new era of personalized spinal care.
It's going to be epic.
All right, so we're back for the final part of our cranial shift deep dive.
Time to wrap things up.
Yeah, and we've talked about what these shifts are, how common they might be, the potential implications for spinal health.
It's been a wild ride.
It has. But I think one of the most fascinating things about this research is that it was focused on surgical cases of AIS.
Adolescent idiopathic scoliosis.
Right. So, what about everyone else?
That's the big question, isn't it? Like, if almost 20% of the surgical AI's population has ACS, what does that mean for the general population?
Right. Could the prevalence be even higher?
It's very possible.
It's like we're seeing the tip of the iceberg and the rest is still hidden.
Exactly.
So then, could ACS be contributing to other back problems, even ones that aren't related to scoliosis?
It's definitely possible. I mean, think about it. If these little shifts can affect the whole biomechanics of the spine,
Right.
then it makes sense that they could be involved in all sorts of back issues.
It's like we've discovered this whole new layer of complexity in the spine.
And now we have to figure out how it all works.
Yeah. So where do we go from here? Like, what's the most important question that needs to be answered?
Well, for me, the biggest thing is figuring out the long-term impact of ACS.
Okay.
We know it can increase the risk of wrong-level surgery, but what about its effects on people's lives in general?
Even those who don't have surgery.
Exactly. Like, does ACS make someone more likely to develop arthritis or disc problems later on? Does it increase their risk of chronic pain or injuries? We need to find out.
Absolutely.
Yeah.
And what about early intervention? Like, if we can identify these shifts early on, could we do something to prevent those problems?
That's the hope.
Mm.
Maybe there are specific exercises or braces that could help manage ACS in its early stages.
So we can stop those problems before they even start.
Exactly.
This is all so fascinating. I feel like this research has opened up a whole new world of possibilities.
It definitely has. And it all comes back to being an informed patient. The
Yeah.
more you know about your own body, the better you can advocate for your own health.
Absolutely. So don't be afraid to ask your doctor questions, do your own research, and be an active participant in your care.
Couldn't agree more.
Well, I think that about wraps up our deep dive into cranial shifts.
I think so too.
We've covered a lot of ground today.
We have. From what these shifts are to how common they might be and all the potential implications for spinal health.
It's pretty amazing to think that these tiny variations in our spines could have such a big impact.
It is. And it just goes to show that there's always more to learn.
Always. So as we sign off, we want to leave you with one final thought to ponder. What if these subtle variations hold the key to a whole new level of personalized spinal care?
It's something to think about.
It is. Thanks for joining us for another deep dive, and we'll see you next time.
Bye, everyone.